Hi friends, in this video we're gonna see what is an Nmos inverter. So this is my Nmos, right? So this Nmos inverter has two MOSFETs connected in series. But with different modes. Right? This is my depletion mode Nmos, whereas this is enhancement mode MOSFET. Okay, so where do we use these inverters is, now whenever we consider to design a NAND gate or NOR gate or any timing circuit, we need this inverter as one of the device to get the output, right? So for that we design this inverter using, here we design using 2 Nmos. The later sections we even design this inverter using CMOS also. That means here we have 2 Nmos transistors. There we use one Nmos and one PMOS. So as it is a depletion mode NMOSFET and depletion mode NMOSFET. What is the difference between depletion and mode and enhancement mode is, in enhancement mode we apply a voltage VGS greater than VT so that the channel is formed and then current flows from source to drain. Whereas in depletion mode the channel is already formed and that MOSFET is continuously on. Without applying any voltage, that MOSFET is always on. Right? Now, here actually this is the structure of inverter, actually the before one, but as the resistor is bulky in size, and instead of that we can use a MOSFET here. Instead of that we used a depletion MOSFET which is always on and acts as a resistive network in this Nmos inverter. Okay, due to size priorities we use this depletion mode MOSFET as a resistive network here in Nmos inverter. So for the depletion mode MOSFET, VGS is 0, right? Gate and source are short circuited and current through gate is 0. So my VGS is always 0 for a depletion mode MOSFET, right? Now when I start initially giving the input to the transistor, this is in one more thing is, we consider this as pull-up network. This transistor is pull-down network, right? This is pull-up network, this is pull-down network. We need this because when we are in the next video we're going to derive the aspect ratio, or there is a pull-up to pull-down ratio of the transistor inverter, okay, using this inverter. So in that case we need this logic. This is a pull-down network, this is the pull-up network. Here I will take my output. Okay, in between we have some demarcation line which separates the input and output lines, right? And here VGS is 0. Now when I start giving the input here, okay, initially this was the resistive circuit, right? Okay, now when Vin is same as VGS, right? Vin equal to VGS is greater than VT, my channel is formed here and current starts flowing. But at certain point it reaches a stage where this pull down network acts as resistive network. That means it transforms into linear region, right? So my input output will be input output characteristics will be in this way. For different values of VDS, okay. Here we see the VDD. This is 0.5 VDD. This is 0, right? At 0 VDD, at 0 VGS of depletion mode, at 0 VGS of depletion mode, okay. When I draw the characteristics of the depletion mode MOSFET, it tends like this, and here I get the intersection points for both these curves, right? This is my input output characteristics of the both the transistors, and these are the intersection points between those curves, and this gives my transfer characteristics to be with respect to V in and V out. I have the transfer characteristics as like this, right? Now this is the line wherein my V in equal to V out. This is the line showing wherein my, that's it, now Y equal to X line, right? This is the ramp line wherein it shows that my y equal to X, that is V in equal to V out. At this stage we consider the voltage to be VINV, inverter voltage, okay. It is termed to be inverter voltage, and this inverter voltage occurs at 0.5 VDD. This should be reminded because it is helpful in deriving the pull up to pull down ratio of this Nmos inverter, right? So whenever my V in equal to V out, at that point, at that operating point, that voltage is called V inverting voltage, and that voltage is given by 0.5 VDD. So V in equal to V out equal to V in V is equal to 0.5 VDD, right? So this is how this Nmos inverter is worked, and these are its transfer characteristics, these are input output characteristics. So basically it has two transistors, two Nmos transistors, one is depletion mode, one is in enhancement mode. That's all for this video. Thank you.